Welcome to Concertal Systems Design Portal, where users gain access to valuable system design automation capabilities that allow them to move quickly from concept to full chip simulation. Concertal SDA performs rapid chip designs by leveraging from high levels of IP reuse. The player's IP library contains SDA integration-ready functionality that can simply be selected by Orchestrate users to define new, complex SoC or FPGA designs. Orchestrate uses a relational database to represent how selected IP should work together to build a system and automatically generates documented designs that can be highly flexible or selectively optimized. This approach supports both rapid builds and quick design changes. If definers require new functionality not found in the player's library, they can specify what they're looking for using Concertal's Audition tool. Audition is used to specify and import existing or new IP into the player's library. Once an orchestrated design is specified, Concertal SDA is used to automatically build behavioral or fully synthesizable designs for simulation using Rehearse. Rehearse is Concertal Systems' server-side simulation engine. It allows users to interactively simulate designs through a Tcl-based web browser interface. Together, players, Orchestrate, Audition, and Rehearse provide a powerful new approach to chip design. The best way to illustrate just how powerful and simple Concertal's system design automation approach is to chip design is to go in, define, and build a new design. We'll begin by logging into the portal. Okay, we're logged in, but before we start designing the chip, let me tell you a little bit about the design that I want to build for you today. The example design is a simple digital signal translator. This part needs to accept input digital signal sources from a variety of places, such as a single channel on-chip signal generator, up to 4 channels of PWM input signals, 1 or 2 channels of pulse density modulated sensor inputs, such as from a digital microphone, or 1 to 4 inputs of SPI input signal data. The part then needs to output signal data from any of these sources to 1 to 4 channels of PWM outputs or 1 to 7 channels of SPI outputs. The part needs to be SPI user configurable. That is, the user needs to be able to select the data paths and the conversions that need to take place. And we want the resulting design to be able to be totally or partially configurable in design. That means that we may need to be able to quickly optimize this into a fixed function non-configurable part. Now, I've already taken the liberty to browse through the player's IP library and came across this list of IPs that I think is suitable for this design. The first IP is a digital signal generator. It's an IP that goes inside the chip and has a configurable frequency, amplitude, and offset to generate a digital sine wave. The second IP is a general purpose I/O. It has 4 pins of GPIOs. The feature set of this IP not only allows the user to program the state, but can key off an event that allows it to generate a pulse, and it has integrated timers so it can generate pulses of specified durations, or it can measure pulses of input durations on the input pins. So it can be used as a PWM generator or measurement tool. The third IP is a serial peripheral interface. It's a standard SPI interface, but it has a variety of configurable modes such as synchronous, asynchronous operation, master or slave. Basically can be used for real-time signal data or control and configuration. And it has up to 16 channels of tag data, so you can actually identify the data that's being input or output. Interesting features. We'll go ahead and use that IP. And then the fourth IP is a digital microphone sensor input. It can operate in a master or slave mode. It has decimating comb filters, so it can accept a pulse density modulated single bit signal and output parallel words. It also has a integrated level control, so that should work for the PDM input requirement of this part. The last IP is something that every SDA generated design will have, and that's the handler interconnect fabric. The auto build takes care of the power on reset, the clock control, prescalers if you want to have them, they're optional, reset controllers, takes care of the data transfers, the wire events, the wire interconnect between the IPs. It also has integrated test and debug monitor ports. So those are the IPs that we're going to pull together in this build. So let's begin by going to New, Create. and select Design. We'll type in a name, hit Create, and we are now specifying a new chip. We know what IP we already want to, so we'll just say Add IP to Design. We'll select the IPs. I've already put them in a list here to make them easy to find. My example design IPs, and we'll begin by putting in the signal generator. Give it a name, and you'll see it gets added to the design database. We will add the GPIOs, and it's 4 pins, so it handles all 4 channels. Once again, that's added to the design. We need to add the serial peripheral interface. And we want to add the PDM input, which is the digital microphone IP. And as you can see, we've added all 4 IPs to the design. Now, we can go and actually begin to edit the properties of these IPs. If we don't specify anything, we can go right into Simulate Design, build the part, and the design that's generated will be a highly configurable design. Since we haven't defined the relationships in the database will assume that it needs the flexibility of allowing any input to any IP to be driven by any output of any other IP. So once again, now that we've specified the design, from this point on, at the single push of a button, we can now generate everything to begin simulating this design using system design automation from Concertal. SDA will build the chip according to the database relationships. It will also build a second test bench design required to create pin stimulus and to monitor pin behavior. And this greatly simplifies interacting with the design through the Tickle Simulation Console and Waveform Viewer. SDA also automatically generates full user guide documentation for both the designs and the test benches it creates. This allows users to begin to immediately and effectively simulate new designs that are created. It's also worth noting that the design shown requires absolutely no CPU or embedded firmware within the design to make work. SDA is much more than just a stitcher. It's much more than an integration code generator. SDA is based upon a powerful system of operation and a supporting chip architecture that facilitates automation and solves complex integration and interoperability problems. For IP providers, SDA offers a way to ensure your IP can be easily integrated and tested within your customers' designs. It also allows you to allow others to experience your IP while protecting access to your valuable source code. For system developers, SDA provides a way to quickly specify and simulate new chip designs without any special chip design knowledge. It can also provide easy access to IP that transcends beyond traditional corporate, team, and geographical boundaries. For chip designers, SDA means increased productivity and quickly reaching RTL sign-off. Concertal's cloud-based environment allows new options for working with product definers and customers, and even involving them in early design specification, simulation, and verification sign-off. It also frees design organizations to concentrate more fully on designing the best IP possible, without worrying about system integration issues. Thank you for watching this introduction to rapid design definitions using Concertal SDA Orchestrate. Please check out our additional introduction videos for more information on rehearse simulation, Orchestrate design optimization, Audition IP specification and import, or other SDA features.